Hello. We're starting off here on Monday by looking at questions people had on the homework packet. This is the second page of the last week's packet. It says page 64 at the bottom. Okay, so it says graph both functions using a graphing calculator. Determine the y-intercept of the functions. Explain what they mean in terms of the problem. So I got to go back. We have some cars getting sold. Tyler recently purchased a new car for $55,000. He also purchased an old car for $30,000. So this is the new, and this is the old. I'm going to write old next to it because I can't. Excuse me. I need your attention this way, and I need you to be quiet, please. The new car, new, will start depreciating. Do you guys know what depreciating means? Decreasing. When you buy a car that's brand new, it costs a certain amount, and as you drive it and time goes by, it's worth less. I mean, it loses value a little bit because it's not brand new anymore. The car will start depreciating the minute he drives it off the lot. So you buy it, drive into the street, the value goes down. Even if you made a U-turn and went back and resold it to him, you wouldn't get your full money back. Okay, so it starts depreciating the minute he drives off the lot and will decrease in value by 10% each year. Because the older car, okay, so let's just talk about the new car. New car started out at $55,000, and it's going to decrease by 10%. So I'm putting some key info there next to the box for new car. The vintage car, the old car, is a different story. It started out at $30,000, and let's see what it says. The older car is a collector's item. It will increase in value by 5% each year. So increase by 5%. Okay, complete the table to show the value of the car after T years. So we talked about this, some of us, and said, I believe this is a compound function. Let's see, time T years for a compound function, P of T is going to equal 55,000. It's not enough room to write it in this little box. Plus, not plus, parentheses. Now this is going to be 1 minus 0.10. I'm going to put that off to the side. 1 minus 0.10 is inside the parentheses. I'm going to simplify it right here because I don't have much space. So that'll be 0.90 raised to the t. Okay, so 1 minus is what happens because this one's decreasing by 10%. Now this one is going to be P of T equals 30,000 times 1 plus, you can't see that, 0.05. So this one's increasing by 0.05. This one's decreasing by 0.10. So this is going to be 1.05 in a simplified form in that parenthesis with t as an exponent. All right, we needed those functions for the questions on the other side. Did you need these questions too, Molly, or did you get that far? Okay, so those functions we needed. Now I believe on the next page we needed a graph. Graph both the functions using a graphing calculator. Determine y-intercepts of the function. So I'm going to go into y equals, clear out the functions that are there. Okay, the first one I'm going to put in 55 1, 2, 3 zeros, parentheses, 0.9, parentheses, raise it to an x. Then I'm going to go down one. Are you with me so far? 30,000, 1, 2, 3, in parentheses, 1.05, close the parentheses, raise it to an x. So those are my two functions. Now I need to set some windows. I know right here it looks like we go from time 0 up to 20. Do we ever go farther than 20? How many years should we put in for our x value? I'm gonna put 40 just to be safe. So I'm gonna go into window, start with a 0 of well, actually I've got 50. I bet you I'll leave it as 50, but I'm gonna go up by ones. I'm gonna go up 1 each year, and then for the y-min, that's the car value. I don't know the smallest number. One car is going up in value, one car is going down in value. I guess I'll leave it at 0, but for my y max, I have 55,000 for one car at the start, and then this $30,000 car. How much do you think is the biggest price we need for cars?
$1 million.
I don't know. You think it's going to get to $1 million car?
No.
Yeah. Well, how about 60,000? We already have one at 55, but that car's going down. 75,000. 2, 3, and
on my graph is like 79,000.
Okay, so we need 80. I'm going to put in 80. Thank you. Good job. 80,000. And I'll make it go up by 100s. Might even need to make it go up by 1,000s. We'll see. Let's make it go up by 1,000s and see what happens. Okay, so graph. There's the car that's going down in value. Here's the car that's going up in value. This is the new car, and it's getting less valuable. This is the old car, and it's getting more valuable as time goes on. Okay, now, what are they asking us first about this graph? Graph both functions using a graphing calculator. Determine the y-intercepts. Explain what they mean. Well, here's one function, p of t equals 55,000 times 0.9 to the t. P of t equals, okay, these are not linear, so we can't just look at the function. This is the new car, this is the old car. So let's see, how about, oh, I know what, let's go to table set, or let's go to table, second table. What do we know about a graph at the y-intercept? What's the value of x? Maybe I need to go. What's the value of x right here? 0. All right, so I'm just gonna, I could do a little tracer thing and try and trace it back, but I could also look in the table, second table, and I gotta look at 0. Here's 0. What do you see for y2? 55,000. What do you see right here for the other y? You guys all right over there? Did it break? Okay.
Heidi says that I need to have 2 other people count it. Can I go to the room?
Do you think it really cheap?
Yes.
Oscar, when did you do that?
It was my binder.
Oscar's trying to
Oscar has a $100 beat right there. I pay for that now.
Well, it breaks like a $1.
I was testing that for last year.
I bet plastic.
Okay, wait a minute. Here we go. Back to math.
Hey, Victor.
Y-intercept equals 55,000. We found it because we knew that the y-intercept is at the place where x is 0. It's on the y-axis. You're not to the right and you're not to the left. Y-intercept for the other function is 30,000. Both of them show up easily in my table when I find x of 0 times 0. Now, what does 55,000 mean in this situation? Where'd that number come from? The starting value of each car. So back to the graph. Bless you. So this is 55,000. This is the new car getting less and less money. And this is the older car who's gaining value over time. Okay? But that's where it's starting at when they were bought. Determine how long it'll take for the new car to depreciate to half its original value. Okay, so wait a minute. What was the original value of the new car? 55,000. What's half of that? It's going to go to half. What do we got? 27,500. So you kind of had to think about this first. What is half? And now we used to do like an intersect feature. I think the intersect feature works better if we only have that function in the graph. So let's go back to our y equals. I'm going to come down here and we're talking about the new car. So for now, I'm going to clear out the function for the old car. I'm going to go up to y1, apparently. You can have it in y2. I seem to be off by 1. And I'm going to put in 27,500. And now I'm going to go second calc, intersect. Gentleman in the back. Okay. Oscar's hiding and Brian's laughing. First curve, enter. Second curve, enter. Guess, enter. So this is the 27,500, which is half of the original value. This function represents what's happening with the car. The intersect right there is x is 6.6, we'll call it, when y is 27,500. Okay? Now wait a minute. What is that 6.6 represent? Years. After 6.6 years, it will be half. I'm probably running off your screen. Value. And first thing we had to do was find half, because it says explain. Find half value. The second thing that we did was use intersection in our calculator. How many years from now will the value of the cars be the same? All right. We're going to have to do intersect again, but I got to go back to y equals, get rid of the 27,000 and put in the other function's equation again. I'd taken it out to simplify my life, 1.05, and raise that to an X. Second, calc. Intersect is number 5. One graph. Second graph. It's going to ask us a couple questions. First curve, enter. Second curve, enter. Guess, enter.
Victor. Jenny.
What do you guys see? Okay, I see an ordered pair, 3.9 and 3.6.344. And I got to look at what the question is. How many years? Which of those numbers is years?
3.9.
So this X value is the years. 3.9 years. They will be equal. Okay, so we're looking at the two cars. That's where they're exactly the same amount. One has come down to that amount. One has gone up to that amount. Hello? Oh, okay. All right, we turned on the TV, but yeah, so you guys don't have Wi-Fi up there.
Wi-Fi.
Okay. I have no idea. What are they watching it on? It would seem like they could. Is it going through a landline? Like it's using a phone cable to get to the internet for me. I don't know how it gets to your TV. Have they tried? Because I think it's a landline. I don't think it's Wi-Fi. I know on my end it's a cable that plugs into one of those phone jacks. Yeah. All right. Bye. They're trying to get hooked up over there on the other school. How are we doing on time? Probably about